Hey, Business 20 students, Mr.D here, and I'm going to be working through some problems on chapter 10 and 11. Ideally, this is really just working through the area of your textbooks that I'm recommending that you go to. So the first one video here will be sections 10.1 all the way through 10.5, as we'll be looking at the various principles around simple interest. And as you know, when you borrow money, you have to pay interest on the money that you borrow. In the same way that when you invest money, you have to, or you get to earn interest on the money that you've invested. And it's really how the whole economic system works. You invest money, that they use that money to make more money with, and or you borrow money and the bank makes money off of you because you have to pay an interest. So interest is always above and beyond your principal amount, whatever it is that you've borrowed, whatever it is that you've invested. And so we need to figure out how much interest we're going to pay. And of course, Sienna, in our Sienna Health and Fitness, she obviously earned some money. She made money by marking up her items, and now she has money either to spend or she wants to borrow money to buy new equipment, whatever it might be. It's a big part of business to either lend or invest, borrow or invest. And so we'll be looking at how to solve different kinds of interest problems and how to figure out how much interest that you have paid or how much interest you have earned if it's an investment or if it is a loan. So obviously, that's what we're going to be looking at first, is what's called simple interest. And this is just basically a lump sum of money borrowed over a period of time or invested over a period of time, and then how much interest that you're going to earn on that money while it's invested or while you're waiting to pay it back. And so that's what we're going to consider. And it kind of comes back to our portion formula that we looked at last week. And we're going to actually be looking at what's called the simple interest formula here in a minute. But it basically, last week we looked at portion, and then we had principal. So this was actually, portion. Then we had base, which was our principal. Then we had our rate. And if you remember, we multiplied those together, divided those to find out the difference. Well, now we're going to add another element, and that is time, T. And the T is very important. It's basically it's adding that into this. And instead of being principal, or instead of being portion now, what we're going to actually have here is interest. So interest or earned, and instead of being base, we're just going to call that principal. So it's going to be principal times rate times time equals interest. Or again, if you divide those factors by the interest, you'll also get the results that you're missing. If you have two of those factors at the bottom and you divide it by whatever the interest is, you'll find the third factor. So you can see here, this is called the interest formula. Interest equals principal times time times rate times time. And so we've already learned how to do the base and the rate and the portion. Now we're going to look at the principal, rate, and interest. But this factor of time has to be looked at in a couple of different ways. Most notably, it's always in terms of years. And so it's very simple. If it's just years, it's just multiplied by the number of years. So if it's 5 years, it would be multiplied by 5, etc. So years always is in terms of numbers. So 1 year, 2 years, etc., 5 years. So if I was to write this formula, it would be, principal times rate times 5 to represent 5 years. However, it's not only true that you can earn interest annually, you can also be calculated monthly. And still, it's put in terms of years. So for instance, when we say, well, I'm going to take a loan out for 8 months, or I'm going to borrow or I'm going to invest money for 18 months, right? Either way, it has to be divided by 12 to put it in terms of years. So when it comes to that time factor, in this case, it would be principal times rate times 8 over 12 to give me 8 months within the year that I'm going to be paying interest. Or in the case of 18 divided by 12, it would be multiplied by 18 divided by 12. And that would be my factor in determining my interest time in months. And so it's either going to be in years, it's going to be in months, or it also can be in days. And so numbers of days, which can also correspond to months, but you might want to put it in terms of days, and many banks do it that way. And so how many days are in a year? We all know that there's 365 days in a year, and 365 would be the factor that you use, and that's what we have here, 365 days. Sorry, there's some mistakes on here. So that's what we call exact interest method when it comes to days, because you're using exactly 365 days. That's how many days are in the year. However, bankers like to use what's called ordinary interest rate, and this is really just doing nothing more than rounding off every month to 30 days. Obviously, some months there's 31 days, some months there's 29 or 28, depending on a leap year or not for February. So it's not exact, but it's more easier to calculate. It's more common to just call every month 30 days. So of course, what's 30 times 12? Is 360 days, and that's what we call ordinary interest, 360 days. I always remember ordinary because it starts with an O, and that just reminds me that 360 ends with a zero. So that's how I always remember. But remember, ordinary interest is 360 days, exact interest is 365. So again, this time factor in your formula for figuring out your interest is going to be however many days. So this problem here says 119 days divided by whatever method. If it's exact, it would be 365 days, or if it is ordinary interest, it would be divided by 360 days. Now you can do these simple interest problems all in one fell swoop on your calculator, and it actually works better to do it all in one fell swoop. So you would take your principal amount, you would multiply that by your rate, and then multiply that by your time, all in one step, one process, one step after the other. So for instance, let's take the first problem here, and we're going to be working on the exact interest method here in problem number 1. Joe Hale goes to a credit union. He borrows $23,000. That is his principal. And then at 8%, so that is his rate. And then his time is 119 days using the exact interest method. So I'm going to take my 23,000. I'm going to multiply it by 0.18, and I'm sorry, 0.808. That's 8%. Remember, to do a percentage, you just get rid of the percent and then move the decimal point over. So 8% becomes 0.08 decimal. 0.08 times 119 days divided by the exact interest method, 365. And what I'm going to get is my interest out of that calculation. So I did the math on that. 23,000 times 8% times 119 divided by 365 equals $599.89. So that's how much interest I'm either going to pay or earn based on this particular loan. Now, in this case, he borrowed the money, so he is going to actually have that $599.84 added to his principal amount. And so if I wanted to know what is the maturity value of that loan, it would be $23,599.89. That's how much ultimately I'm going to pay by taking out that loan. Now, that's using the exact interest method for the days. If I was to do the same problem, which I have here, same problem, this time I'm going to do $23,000 times 0.08, 8% times 119 days, but I'm going to use the ordinary interest method, as it says there, so 360. And I'm going to do the math on that. So I did the math, 23,000, 8%, 119 days for 360 for an ordinary interest method. It comes out to $608.22. So that's how much interest. Now, notice I paid a little bit more using the ordinary interest method, which, by the way, is also called banker's interest. And this is typically what they want to use because there will be a little bit more interest paid. Typically, what a bank will do is when you borrow money, they're going to use ordinary interest. And when you invest money, they're going to give you exact interest, which will be a little less. So that's kind of how they do it in many cases. So this is how you work out these kinds of problems. Now, I did it, both of these problems, I did it using days. Again, you could do it using other time periods, depending on what the requirements are. So if I did 23,000.8 and I wanted to do it in years, say 2 years, I would figure out how much interest that is by multiplying those together. If I wanted to do it in months, because that's the terms of the loan, they're not the same. Let's just say it's 6 months. So actually, let's make it 7 to make it more fun. 7, 12. So I would multiply that all together in the same way, 23,000 by 0.8%, or 0.08 decimal times 7 divided by 12, and that would give me how much interest I'm going to pay in that period of time. So, all right, well, let me look, or how much I will earn. So let's look at the next problem here at the bottom. This is another one, 15,000 at 9.5%. I apologize, that didn't come out right. 9.5% interest for 250 days using the ordinary method. So again, if I follow the formula, I'm trying to find interest. So I'm going to start with my principal, 15,000. I'm going to multiply that by 0.095, one half equals 0.5 or 0.05 when it comes to converting. So I'm just going to add the 5 there, and 0.095. And by the way, I don't usually use half percentages, but I am here. And then it's 360 because it's ordinary interest. So I would do the math on that. I did the math. 15,000 times 0.095 times 250 divided by 360 comes out to 289 and some change, 58. So I'm going to pay on that loan at that high interest rate. I'm going to end up paying in 250 days an additional $989.58. So again, what is my maturity value of that loan? Is $15,989.58. So that's adding the interest in. That's now my maturity value of that particular loan. Again, if it were going the other way and it was an investment and I made that much interest over that many days, I'd be adding that 989. And instead of only having 15,000 in the account that I'm doing, I would have $15,989.58. So that's the simple way of calculating simple interest. We're going to move now into maturity value. All right, those last problems that we worked out, in order for us to find the maturity value, we just added the interest that was accumulated, whether that be in a loan or an investment, and we just added it to the principal. And if you see here at the top of the screen, this is section 10.3 from your book. Maturity value equals principal. That's the original amount you invested or borrowed plus the interest. And that's why I kept calling it the maturity value. That's the amount that it is now worth at the end of that loan or at the end of that investment. There's another way you can automatically factor that in right away if you want to, and that's to use the maturity value formula, which is basically what you'll do is you'll add 1 to the rate, and that'll ultimately lead you to getting the maturity value in your answer. And so it actually looks a little bit differently than that. The better way to write that formula would be maturity value equals principal, and then 1 plus rate and time. And whenever you have this in math, you always start with the multiplication first and then do the addition last. And so in order to get that, if I go back to the original problem that I just did, I think it was $989. Let me see, I think I still have the result here. I don't. Give me just a second. So looking at the problem we just looked at, 15,000 times 0.095, which is 9.5%, times 250 divided by 360, we had the total of interest, or total interest of 989.58. Now, if we took this maturity value formula and we reworked it, what we would do is we would first start with our 15,000 again, multiplied by the 1 plus, and then we would do the rate and the time. So that's how we do it. So what's rate times time? So in this case, 0.095 times 250 divided by 360. That's the first thing that we would figure. So that comes out to 0.065972. Let's put. It's really not good to round too quickly. So that becomes now our 1 plus that becomes 1.2065972. So what I'm going to do is I'm going to multiply again the 15,000 times 1.6559. Oops, I didn't do it right. So 15,000 times 1.065972, the answer to that is 15,008, oh, excuse me, 989.58. You can't see that. I'm going to write over here. It comes out to 15,989.58. So all I did by adding that one is I added the $15,000 back in. So that's a faster way of finding maturity value, but it's just as easy to find the interest first and then to figure out, add the interest to the principal, and then you have what's called the maturity value. All right, well, now we're introduced to what's called the simple interest formula, and it's very similar to what I had shared with you guys last week, as I mentioned this right here. They use a triangle in your book, and as it says right below it, we figured out interest by multiplying the principal times the rate times the time, and that time could be broken into years, months, or days. Now what we're going to do is we're going to begin to solve for the other factors. So for instance, if you look at the problem, and this is, by the way, section 10.6, using the simple interest formula, is we're going to try and find what is the principal. So if you read the problem, Telex Electronics borrowed money at 9% interest for 125 days. If the interest charge was $560, use the ordinary interest method to calculate the amount of principal of the loan. So if I'm using this formula here, what I'm trying to find is this factor, the principal. So I know the interest, right? The interest was $560. And then I know my rate is 9%, so 0.09 times 125 divided by, and it says to use the what? Ordinary interest, so 360. And then I'm going to divide those two together. But I want to start by solving the problem on the bottom first so that I get an accurate denominator. All right, so I want to solve the bottom first. So 0.09 times 125.360 equals 0.0312. That's going to be my denominator. I'm going to divide that by 560. And when I divide that by 560, my answer comes out to $17,920. So that is going to be my principal amount. That's how much I invested in this particular investment, or how much Telec Electronics borrowed was 17.9. Now, if you want to check it, you can literally just go across the bottom and punch in the 17,920 there. You can punch in the rate of 9%, and you can punch in the time of the 125 divided by 360, and you will come up with 560. So I highly recommend you check your answer by, filling everything in and then doing the math and seeing if you get the right answer. If you don't get the right answer, something went wrong somewhere. So in this case, if you multiply those together, so again, 17,920 is the principal times 0.09 times 125 over 360. And my answer will be $560 of interest. All right, so that was solving for principal. Now they want us to solve for rate. And that's what the next problem does. Again, we can use the same formula that we have here. I like to use it as a circle, but I'll go ahead and do it as one here. Interest, principal, rate, time. You multiply these together, or you divide here. So we're going to do the second problem. This time we're trying to solve for rate. So what that formula kind of looks like is, if you were to draw it out, as interest divided by rate equals interest divided by principal times time. So again, what's our principal amount here? We'll start. We know the interest. The interest is 1960, so we'll just draw it the way that it's here. Our principal is 25,000, and our time is 245 days divided by the ordinary method, so 360. So the first thing we need to do, of course, is multiply the bottom part here. So that's going to come out to $1,713.8888. I'm going to do it that way. 1960. Then I'm going to divide those two together, and that's going to come out to 11.110. Sorry, 1152000, something like that. And of course, if I was to convert that decimal to a percentage, it would come out to 11.52%. So that is my rate based off of this formula here, which is the same thing as here. So I came out to 11.52%. So it says here, round your answer to the nearest hundred. So that's why it's 0.52. And that's how I found the rate. I basically just divided the principal in this case and the time divided by the known interest, and that gave me my rate. All right, the last one we're going to be solving for what is the rate on the loan? Is this the same problem? It's the exact same problem. So we'll move on. All right, the last one is solving for time. And unfortunately, I didn't include the correct question on my worksheet here, but I'm going to go ahead and read you the question that is relevant to this. And it is, what is the time period? So what is the time? That's what we're trying to find out. For a loan of $15,000 over at 9.5% interest, so 0.095. And the interest amount was $650. So the interest was $650. And they want us to solve what is the time. So how long was this loan in place? And so again, if we use the same formula, we have the interest, which is $650. We have the principal, which is $15K. And then we also have the rate, which is 0.095. But what we don't have is this time. So we're going to do the same thing. We're going to multiply 15,000 by 0.095 first, and then we're going to divide that. Actually, another way to look at this would be time equals interest divided by principal times rate. So that's how we find time, whatever factor is missing. So we're going to do this 15,000 by 0.095. That comes out to 14,000 or 1,425. And I'm going to divide that by my interest. And that comes out to, when I divide those together, 0.45614. So we're going to take the 20,600, multiply it by 12%, 0.12, and then multiply that by 98 divided by 360, and our result comes to 672.93. So that's how much money she will earn by doing that 98-day investment. Now, if it were me, I would probably invest that 20,600. I'd wait 98 days to buy my blenders, and then the money that she just earned in interest would cover the interest that she's going to be spending by taking out the loan, and she would still have her 20,600 in the bank at the end of the day. So that's the two of the problems there for Sienna. Now, as we move into the last section here, which is 10.9, and all of that, by the way, was 10.7. All that we just covered was 10.7, 10.8, 10.9, and now we get to, or 10.8, now we get to 10.9, which is calculating a loan involving partial payments. So this one here, we're going to basically be looking at a time frame of 100 days. And the person that's taking out this loan for 100 days is going to be making payments to it. So they're not going to get charged the full interest on the full amount for the entire loan, but they're only going to be charged interest on the period in which they didn't make a payment. So for instance, this loan was taken out for $15,000, and ultimately it was for 100 days. However, they made a payment, as it says here, on day 20. So they're only going to pay interest for 20 days on that initial $15,000. And so that's how we have to figure it. So we know they took out $15,000, but how much interest did they accumulate over those 20 days? So I need to figure that out first. So 12% times 20, and it's using the ordinary interest method. So 360. Let's do the math. We do the math on that, it equals $100. So 15,000 by times 12% for 20 days, that's how much interest that loan accumulated. So now their balance, rather than being 15, was 15,100. However, they made a payment of $4,000. So we need to first deduct the new interest, minus, not plus, means that only of their $4,000 payment, only 3,900 was applied to the principal amount. But because they made a payment, that $15,000 now is basically minus 3,900 because they made a payment. So now that comes out to $11,100. So their new balance after the first payment is $11,100. So if they were just to figure out the remainder of those days, they already used 20, so it would be 80 days at 12% interest would be their total amount. However, they make another payment on day 60. So because of that, they have the $11,100. Sorry, did too many zeros there. They did $11,100. We're going to multiply that by 12% interest, and we're going to multiply that by day 60. Now, if it's day 60 and we already did a one payment on the 20th, how many days is left? 40. So there's 40. So from day 20 to day 60 is 40 more days. And so we're going to figure out how much interest did she accumulate over those next 40 days. So we got to do the math on that. And we realize that's $148. So the additional $148 was added because on day 60, she makes a $5,000 payment. And I have to minus that interest that was charged off of the payment. So that comes out to $4,852. That's their payment amount. So I'm going to deduct that from the 11,100 minus 4,852. Equals $6,248. So that's now my new balance after I made the second payment. And again, there's still how many days left on the loan? Well, 60 days, they made the next payment. So I have a 100-day loan. So I have another 40 days. So I need to figure out the remaining interest on that. So $6,248 times 0.12 times 40. 360 divided by 360. So I need to figure the interest on that last section of the loan. And that amount comes out to $83.31. And if my previous balance was $62.48, that's what I owed at day 60. But because I have to add the additional $83.31 to that amount, means that I now owe at the end of this loan $6,331.31. So that is my maturity value of the loan after the partial payments on day 100. So you'll be working problems like that, and these will come up in later chapters. So make sure whenever you're figuring out interest that you have to figure it out between those partial payments, how much interest was accumulated. You can't just do the whole amount at once. You have to do each segment that before a payment is made, how much interest did they earn or how much interest did they accumulate? And that needs to happen on those. So that's pretty much it from 11.1 all the way to 11.9 in our book. And now we're going to get into the last section, which is what we call promissory or discount notes. And that's going to be on a separate video.